students, today we are going to learn the topic Oscillations for 12th standard. The first point in this topic is periodic motion. What is meant by periodic motion? A motion which repeats itself. A motion which repeats itself after definite interval of time. त्याच कालावधीमध्ये रिपीट होत असेल itself again equal or same interval of time, that motion is called as the periodic motion. Next point is oscillations. What is meant by oscillation? A body performing periodic motion, जी body periodic motion perform करते, goes on repeating the same set of movement, again and again. One such set of movement is called as the oscillations. त्याला एक oscillations असं म्हटलं जातं, which goes on repeating the same set of movement again and again. One such set of movement is called as the oscillation. Next, what is meant by periodic time? Time taken by particle to complete one oscillation. एक oscillation कंप्लीट करण्यासाठी लागणारा कालावधी म्हणजे periodic time असं त्याला म्हटलं जातं. Time taken by particle to complete one oscillation is called as the periodic time. What is meant by oscillatory motion, or it is also second name is vibratory motion. Oscillatory motion means what? The periodic motion of a particle. The periodic motion of a particle repeatedly moves to and fro, पुढे आणि पाठी, to and fro, again and again along the same path is called as the oscillatory motion, or it is also called a vibratory motion. Oscillatory motion, pendulum in a clock which oscillate about its mean position. Such motion is called as the oscillatory motion. Vibratory, needle of swing machine which vibrate about its mean position. Such a type of motion is called as the oscillatory or vibratory motion. What is meant by period of oscillation? Time taken by or very short interval of time taken by the particle to complete one oscillation or vibration is called as the period of oscillation or period of vibration. What is meant by frequency of oscillation? What is meant by frequency? Number of oscillations performed by particle per unit time. प्रत्येक युनिट टाइमला पार्टिकल किती ऑसिलेशन काढतो त्याला काय म्हणायचं? फ्रिक्वेन्सी. जनरली इट इज रिप्रेझेंटेड बाय लेटर एन. इट इज periodic time is represented by capital T. The next point is definition of linear simple harmonic motion. What is meant by linear simple harmonic motion? In this case, we have to explain linear simple harmonic motion. The motion in which every particle of body, the motion in which every particle of the body moves to and fro. एखाद्या बॉडी मधला पार्टिकल, प्रत्येक पार्टिकल बॉडी मधला पार्टिकल हा टू अँड फ्रो, पुढे आणि पाठीमागे काय करतो? ऑसिलेशन करत असतो अबाउट इट्स मीन पोझिशन अगेन अँड अगेन along the same path and straight line. That type of motion is called as the linear simple harmonic motion. एखादी व्यक्ती पुढे गेली, ही मीन पोझिशन आहे, ती पुढे गेली, पुन्हा इकडे आली आणि पुन्हा या दोघांच्या मध्ये जर ती पुढे मागे करत असेल about its mean position, then such a type of motion is called as the linear simple harmonic motion. Now we obtain the differential equation of linear simple harmonic motion. We also study, or we also explain the periodic motion, also explain the linear simple harmonic motion. The motion of the particle about its mean position in a such a way that the force acting on the particle or acceleration acting on the particle is directly proportional to displacement. म्हणजे इथून इथं डिस्प्लेसमेंट झालं, पार्टिकल इकडे ओढला जातो, इकडे डिस्प्लेसमेंट होतं, परंतु बलाची दिशा मात्र इकडे असते. असं ज्या वेळेला होतं, उदाहरण स्प्रिंगचं घेतलं, स्प्रिंग उदाहरण घेतलं, इकडे ओढलं तर मात्र डिस्प्लेसमेंट इकडे होतं आणि स्प्रिंग सोडली की इकडे येतं, म्हणजे फोर्स इकडे आणि डिस्प्लेसमेंट इकडे. इन दिस केस द फोर्स ऍक्टिंग ऑन द पार्टिकल is directly proportional to the displacement or acceleration of the particle is directly proportional to displacement. Then such a type of motion is called as the linear simple harmonic motion. In this case we have to find the differential equation of linear simple harmonic motion. The force is directly proportional to displacement. Negative sign indicates that displacement and force are oppositely directed. Therefore, F is equal to minus kx where k is constant. K काय आहे? हा constant आहे. K is constant called proportionality constant. It is called a spring constant. हा spring constant आहे और oscillatory constant सुद्धा याला म्हटलं जातं. Therefore, we write from the Newton's second law of motion F is equal to ma. किंवा according to Newton's law of motion F is equal to ma, equation number 2, F is equal to minus kx, equation number 1. From equation 1 and 2 we write ma is equal to minus kx, याला equation number 3 देऊया. Velocity is defined as displacement divided by time, किंवा rate of change of displacement with respect to time is called velocity. Acceleration is defined as rate of change of velocity with respect to time. Therefore, here A is equal to acceleration is equal to d by dt, v म्हणजे dx by dt. Therefore, A is equal to d2x by dt square. Equation number 4. या इक्वेशनला इक्वेशन नंबर 4 म्हणूया. या ठिकाणी आता A ची किंमत काय करूया? इक्वेशन नंबर 3 मध्ये ठेवूया. Substitute the value for A in this equation. Therefore, this equation can be written as m into A means d2x by dt square is equal to minus kx. Therefore, m इकडे आणून divide केला, d2x by dt square plus k by mx is equal to 0. But omega square is equal to k by m. Angular velocity असते k by m. इथं आपल्याला ओमेगा स्क्वेअर ची किंमत इथं अशी लिहूया. याचं एक्सप्लेनेशन पुढल्या भागात आपल्याला मिळेल. k by m is equal to omega square. K by m is equal to omega square. Therefore, d2x by dt square is plus omega square is equal omega square x is equal to 0. This is the differential equation of linear simple harmonic motion. हे differential equation आहे. परीक्षेला 2 मार्काला हे नेहमी विचारत असतात. Now we have to find the acceleration or acceleration in linear simple harmonic motion. In linear simple harmonic motion, okay? We know that differential equation d2x by dt square plus omega square x is equal to 0. Therefore, हे इकडे घेऊया. d2x by dt square is equal to minus omega square x. Therefore, याला म्हणतात acceleration A. हे आहे तसं. Therefore, acceleration is equal to minus omega square x. This is the acceleration in the linear simple harmonic motion. Now, we explain the velocity of particle in linear simple harmonic motion. The velocity in linear simple harmonic motion. That is, we find the velocity of particle in linear simple harmonic motion. We know that आपल्याला माहित आहे काय d2x by dt square is equal to minus omega square x. So here we write this equation, we write d by dt into dx by dt is equal to minus omega square x. आहे तसं लिहिलं 4 केली फक्त. But dx by dt is equal to dv by dt, म्हणून d by dt into ह्याची किंमत v आली. dv by dt is equal to minus omega square x लिहिलं. इथं जरा पोट केली, आपण dx न मल्टिप्लाय केलं, dx न डिवाइड केलं, dv बाय dx इंटू dx बाय dt इज इक्वल टू मायनस ओमेगा स्क्वेअर x असं आपण या ठिकाणी लिहिलं. परंतु dx बाय dt म्हणजे काय आहे, v आहे, म्हणून v लिहिलं, इथं v लिहिलं, हा dx इकडे घेतला, v इंटू dv इज इक्वल टू मायनस ओमेगा स्क्वेअर x इंटू dx लिहिलं. इंटिग्रेटिंग दिस इक्वेशन, या इक्वेशनचं आपण काय घेऊया, इंटिग्रेशन घेऊया. Therefore integration v into dv is equal to integration minus omega square x into dx. Therefore integration चा फॉर्म्युला integration x into dx is equal to x square divided by 2 plus constant of integration असा फॉर्म्युला यूज करूया. इंटिग्रेशन v into dv is equal to v square divided by 2 मायनस ओमेगा स्क्वेअर कॉन्स्टंट आहे, बाहेर घेतलं, integration x into dx x square divided by 2 plus c is the constant of integration, that is c is constant of integration. We now define amplitude. What is mean by amplitude? हा पार्टिकल या पाथला काय होतं, मागे पुढे होतं, ही मीन पोझिशन आहे, ही एक्स्ट्रीम पोझिशन, ही एक्स्ट्रीम पोझिशन, असा जाणार पाठी येणार, असा पुढे पाठी. This position is called extreme position. This position is called mean position. Now we define the amplitude. The maximum displacement of particle from its mean position. Maximum displacement of particle from its mean position is called amplitude of the motion or amplitude of the particle. Now at extreme position, particle इथं आला किंवा इथे आला, तर at extreme position displacement is equal to a, इथून इथं a झालं, and velocity is equal to v, कारण इथं आल्यानंतर पार्टिकल थांबतो, पुन्हा पाठीमागे जातो. x is equal to a and v is equal to 0. Substitute this value in this equation. Therefore we write x is equal to v is equal to 0 minus omega square x square म्हणजे a square divided by 2 आहे तसं plus c. Therefore 0 is equal to omega square a square divided by 2, that is c is equal to, we have direct obtained from this equation, c is equal to omega square a square divided by 2. Substitute this value in equation number 1, we can write v square divided by 2 minus omega square x square divided by 2 plus c means omega square a square divided by 2 to get cancel, v square is equal to minus omega square x square plus omega square a square, omega square common घेतलं, v square is equal to omega square into a square minus x square. Therefore v is equal to plus minus square root of a square minus x square. With the help of this formula we can determine the velocity of particle in linear simple harmonic motion. Now we explain the displacement of particle in linear simple harmonic motion. आता डिस्प्लेसमेंट आपण काय करूया, फाइंड आउट करूया, आणि तो आपल्याला पार्ट त्या ठिकाणी पाहता येईल. व्हॉट इज मीन बाय displacement, or what is the formula for displacement of particle in linear simple harmonic motion. Okay, here we know that the velocity of particle is given by formula p is equal to dx by dt, and acceleration is given by formula a is equal to dv by dt. The velocity formula also we can write v is equal to, or v square is equal to omega square a square minus x square. velocity formula असा आपल्याला मिळतो. आणखीन आपण वेगळ्या पद्धतीने हा फॉर्म्युला लिहू शकतो, that is dx by dt. v means also v is equal to plus minus omega into square root of a square minus x square. V is equal to this equation number 1, this equation number 2. From these two equations we write dx by dt is equal to omega into square root of a square minus x square असं लिहू शकतो आपण. हे dt इकडे घेऊया. मग हे इक्वेशन आपल्याला कसं लिहिता येईल? dx is equal to omega into dt. हे इकडे आणून डिवाइड करूया. a square minus x square. Integrating this equation, we write integration dx divided by this is equal to integration omega into dt. याचा डायरेक्ट फॉर्म्युला आपल्याला मिळतो sin inverse of x divided by a is equal to omega constant time integration dt is equal to t plus phi is the integration constant. Therefore sin inverse इकडे घेतलं वरती तर x divided by a is equal to sin of omega t plus phi हा फॉर्म्युला मिळेल. Therefore displacement of particle x is equal to a into sin of omega t plus phi. This is the displacement of particle in linear simple harmonic motion. This formula gives the velocity of particle in linear simple harmonic motion and acceleration in linear simple harmonic motion is equal to minus omega square x. These three formulae is important for mathematical calculation. Acceleration is equal to this velocity and displacement of particle. Now we explain the particles start from mean position and particles start from extreme position in linear simple harmonic motion. This is the first case. Particles start from mean position. This is the mean position, extreme position, extreme position. Particles start from mean position. Therefore, x is equal to 0 at t is equal to 0. Particle कुठेही गेला ना इथेच आहे. t is equal to 0 and x is equal to 0. There is a no displacement. Substitute these two values in displacement formula. Displacement formula x is equal to a into sin of omega t plus phi. Therefore x is equal to 0 is equal to a into sin of phi. T is equal to 0. Therefore only sin phi. Therefore sin phi is equal to 0. म्हणून phi is equal to 0. ही किंमत इथं ठेवली. मग कसं लिहिलं? x is equal to a into sin of omega t. Thus particle start from mean position, then the displacement is equal to x is equal to a into sin of omega t. Particles start from extreme position, second case. आता पार्टिकल इथून सुरुवात होणार आहे. इथं मीन पोझिशन ह्या अंतराला एम्प्लिट्यूड म्हणतात. इथून सुरुवात होणार आहे म्हणजे t is equal to 0 आणि इथून इथं अंतर किती आहे? a आहे. म्हणून x is equal to a at t is equal to 0. Substitute these two values in displacement formula. X is equal to this. Therefore x is equal to a. हे आहे तसंच t is equal to 0 omega t 0 a into sin phi. a get cancel. Sin phi is equal to 1. केव्हा येतं? phi is equal to pi by 2 असेल तेव्हा येतं or 3 pi by 2 असेल तेव्हा मिळतं. म्हणून x is equal to a into sin of omega t plus phi इथं ती लिहिता येतं आणि sin of omega t plus phi म्हणजे cos of omega t. Thus particles start from extreme position. The displacement of particle x is equal to a into cos omega t.